Welcome back. And we are here with Nick Jushchyshyn. And Nick is going to be talking about reality capture. This is something, a lot of us build models, and photogrammetry has been around. My first photogrammetry project was 30 years ago. But it was very manual. Like, we basically, you take a couple shots and you put a box in the middle. And you start figuring out where all the things were, and you were manually the big jump from there was Image Modeler, which Nick was on. Nick worked on inside of Pixel Core and other things with Image Modeler and other things like that. And the technology has gotten so much better. A lot of the stuff has every year it feels like it just jumps by leaps and bounds. And Epic, of course, bought reality capture. I don't know, a couple of years ago. I don't know exactly when, but a couple of years ago, and has maybe 4 or 5 years ago. And now there's been a big change in the cost structure. So reality capture, a lot of us were like, "Hey, that's really great," and then we looked at the price and we're like, "Hey, that's really expensive." And so then that was and this is a good example of a great technology that was hidden for a long time behind a poor business model. Epic was able to take advantage of that and buy the company. Then Epic created something that was really confusing. I don't think it was not very expensive, but it was confusing. The token system was confusing. But now, Nick, they've taken that and made it much easier to use. Is that right? Oh, can't hear you. Can't hear you, Nick. Nick, I don't know if you can hear me, but I can't hear you.
There's that minor detail, that mute button still. 4 years into
hardware
Zoom.
Mutes are really your friend.
Yeah.
So anyway.
And I apologize if, let me know if my audio volume is, I'm working at a different studio today and I don't have my crew to help me out. So that the token system actually predated Epic's ownership of the company and the solution. So that was the company's approach to making it accessible. And what it did was, you either could have it expensively or you could not have certainty as to how much it would cost you to create a model, because the token system was based on, price per image and the resolution of the image and all. And so you couldn't just go making 3D models of anything and everything, because if you were using the token system, you were trying to decide based on, well, how many pixels do I have budget for? And you could
and the problem is it's just that was written by somebody who was thinking of business models, not someone who actually does production. Because what it does is anytime you start charging like that, you clamp down on people's creativity. They'll think differently about your product. Like they just think like, oh, I don't understand. Like, I don't know how much that's going to cost. And then it makes them stingy to use the product. And then that makes the product not work as well. I know for me, as I was doing, I had I can't think of the name of it right now, Metashape, and I was trying to think of what it was before that, but Metashape. And for me, I paid a monthly fee. I still pay a monthly fee for it, and I'm able to just use it, and I don't think about like how many this is going to take or what it's going to take, and I just use it up. And I felt like when I tried to test it before and even during this previous business model, I just found the token thing to be really just made me nervous, like made me stressed, and then made me not want to use it. And so it just ceased to exist for me. And I think it's a great technology, but the business model was really convoluted.
Yeah, it was actually a little different than that. It was you could actually get all the way to the finished model.
I know,
but it was when you output. It was when you actually output.
Yeah, it was a horribly dumb idea. Like it was just dumb. Like it was dumb to make us think about that. Like it was like, it's not thinking like an artist, it's thinking like a CPA, and it's where business people ruin good models. Is I get that they made that argument, but it was a goofy way to do it. And I don't want to make it about that. What I'm saying is that the good news is that it's now not that way. They fixed it.
It's not,
right?
Exactly. Yeah. I mean, Epic has gone ahead and made it really simple. So if you're making less than $1 million a year, it's free.
Yeah. End
of story. And if your revenue, whether it's at an organization level or if you're an independent contractor, if your revenue per year is over $1 million, there's one fee, $1,800 for the year for a seat of reality capture, twin motion, Unreal Engine. So all of it is included in that, and explicitly Reality Capture, Unreal Engine, all of these tools are completely free for students, educators, hobbyists, and anyone that's learning the tool and not actually using it to
I have to say, what a brilliant business model! Like a brilliant business model. It is. I feel like most companies should really think hard about this business model, because it doesn't affect most. If you're a big company selling Maya or selling, even many other products, you're not making money on folks making less than $1 million a year. Like that's not really where your bread and butter is. And so being able to give them that builds, because one of the things is that you have to find people. You have to have enough. Like when I look at what to use for a company, I have to think about how many people can I hire to do that? Like, do they know how to use the product? And this is really ensuring that a lot of people are going to know how to use the product, right?
Right. And the thing is too that Epic has, their entire ecosystem includes being able to sell the assets that you create on their own asset marketplaces, and they've got further improvements on that coming. So conceivably, with Reality Capture, Blender is free, and Unreal Engine, you could capture, unique world things that are in the real world, make a 3D model asset out of them, or a collection of those assets, and put them out onto the marketplace. You've spent nothing, and name a price, and anyone in the world can now purchase those things, and you can monetize that. And so I think that's an incredibly powerful way to incentivize folks to get started with these technologies. And because it is a full ecosystem from, okay, you've got your images from a camera, and that could be your cell phone or anything else, through going ahead and creating a finished asset that you can actually monetize. It just makes it a really, really friendly experience and a really streamlined experience. And so I think it's a great thing to get started with. And even if that's not the route you ever go, it's just, one of those little candies that'll make you feel good thinking about that and help, move you forward when you're getting started.
So you put together a little demo.
Yeah. Let's see if I can share my screen.
And one of the things that Nick did, by the way, if you'll watch a little of it here, and you can ask questions as we work through it. But Nick put together a video. The link went out in the email, and so you can actually and we'll make sure that the link goes into the description here, of kind of a walkthrough of that process. And so I think that's we're trying to work through that. When you see those links in the emails, one of the things you can do is watch this ahead of time so that you get a little bit of a head start. So where did you shoot this?
So there's a cultural heritage site in my area called Longwood Gardens, and they have 1,000 acres at one location alone, and there's all sorts of topiaries and statues and all. And so the funny thing here is I took around 400 photos, and my intent, and I took these photos years ago, so I didn't remember exactly what my thinking was or process. I just figured that, okay, these are concrete, these are going to solve really well, and I'm just going to switch to a different app for a second. Like, this is what I was looking at when I was picking out the photos, is like, oh, I've got all these photos of this statue, so I'll go ahead and feed them to Reality Capture and solve it. What I didn't realize as a human being looking at 400 photos at once was that I actually photographed 2 statues. And so I'm actually really impressed that Reality Capture noticed this and solved for all the space in between, even though I didn't if I intentionally wanted this space, I would have had camera, photography of this surface, and you'd see like each one of these little pyramids is one of my camera photos. And there would be a cloud of those in the middle if I had done this intentionally, but somehow Reality Capture noticed and figured out, oh, this is 2 different statues, and here's the result. So I'll make this a public video. Right now it's unlisted, but I'll list it on my channel so that if anyone wants to look into this. But the main thing here is that I was outside on an overcast day, so there's no direct sunlight and heavy shadows. And even in that condition, these statues are under trees, so they're fairly smoothly lit, and they're made of dry concrete or stone, so there's a lot of surface texture on them. If I were to like double click on one of these images here just to take a closer look. So you can see that, there's a lot of surface detail on these, but it's not reflective. And so this is really kind of like the ideal recipe for something to process with photogrammetry. You take 100 or more photos of something like this, and you're going to get a good result. And the good result is a 3D model. So I think in my demo, I was using in this workflow tab, I just hit the start button and it processes everything automatically. But under the hood, what's happening is three different major steps.
And a big thing is the, you can, a lot of these things will do a lot of automatic processing, but the real skill often is taking the photos, right?
Absolutely. Yeah. And reality capture built into the software. If I go in, let's see this main page, and I can go to hopefully I can click this button and select help. In here, there is all sorts of tutorials, and I think one of these includes useful workflow tools somewhere, and I've shared links. Oh yeah, here it is. Learn more, how to take pictures. So in the help screen itself, you can go to a tutorial from the folks from Reality Capture, and they have a really good guide about how to take those photos. And it involves, again, if we look at my photo collection here, you want to have a lot of overlap similarities, but from one photo to the next. But also, as we look at the result here of my own shoot, is that you want to make sure you're moving the camera around, and not just horizontally and around, but also vertically. So, I was making sure to shoot low and high, and all of this essentially turns your camera into a constellation of GPS satellites. And the software is able to calculate and triangulate the surface of the objects as well as the positions of the camera based on all of this overlap.
The step first is that the camera is going to use the information that you have. It's going to grab a bunch of points that it sees that are similar between cameras, and then it can use that to reverse engineer where those cameras had to be for those points to be falling off at the rate that they are. So the reason I say that is that a big flat surface is harder than something that's got a lot of detail and some geometry to it, right?
Absolutely right. So if it's something like a piece of black acrylic, and so the color is completely uniform, and it's also reflective, so that as you move around, there's some specular highlight or a light kind of moves across its surface as you're moving around it. That's going to throw the calculation off, because under the hood, what's happening is an image, a pattern recognition machine vision system that's trying to identify unique patterns. And what we're looking at right now is the point cloud that was calculated. So this isn't necessarily the 3D model. If I zoom out with my mouse wheel, we can kind of see the three-dimensional shape. But what we're looking at here is a point cloud. And if I look at my project here, this is a list of all the images.
Well, so what happens if you have a pile of images? You went out and took a couple photos. Mm-hmm. Can you walk us through from the very beginning, like just with a blank page, like this is what it would look like when I walk in? So you've got this.
Sure.
Yeah, funny.
So
laying around.
So
all right,
so
you have the images. What happens next?
So I'll add the images to the project. And in this case, I'm going to use a much simpler thing where I only have, a few images, and it's a stone wall. So even though it's a wall, it's not really flat. It's got a lot of relief and stones in it. So I select those, and now those 25 images are here in the project, ready to go. And so the first step, instead of doing auto, I'll go step by step. So the first step really is alignment. And I'll hit alignment here, and it'll take less than a minute to analyze these 25 images and create an alignment that aligns the source camera position of each image relative to the surface and relative to each other. And so this is that result.
And the points are the points that it found to use to find the cameras.
Exactly. So each one of these little pixel specks is a unique three-dimensional point that I identified across the 25 images. And up here in the upper left, I've got a variety of panel views that I can select from. So I can select a view that gives me 4 viewports, for example, and I could look at images as well as the 3D model simultaneously. So that's one step. there. The second step is to create a mesh 3D model surface from all of these points. And so that's the mesh model step. I'll click on normal detail for this. And this is going to take a little over 60 seconds. So I'll just let that cook a little bit. But under the hood, what's happening here is it's measuring distances between each of these points and identifying what is a good triangle of a surface to fill in. And it'll fill that in essentially, like a little jigsaw puzzle.
I think for the folks in the back end, we should be looking at the screen. Yeah.
What's that?
We just need to be looking at the screen here. We need to see the screen. Yeah.
Okay.
Yeah. So it has to figure out the points that are nearby each other, how they interact with each other, and it's building mostly triangles.
Exactly. Yeah. So in reality capture in particular, it creates triangle meshes. And, for something like this, we might get a few million triangles, even though it's just a small
And at this point, it's not doing any decimation, right? The decimation is the...
Correct.
So a decimation for those listening is really where it looks at... You can have a lot of detail in a flat surface, and it says, well, I don't need all that detail. We can get rid of it. And based on the break angles between the polygons, we can reduce some of that detail, and we won't lose any. And you can, depending on how you turn it up, because sometimes, for instance, if this generates too much, we can't even open it on if you want to send it to someone with an iPhone with, let's say, USDZ, you've got a 50 meg limit on the texture and the geometry, so you may have to reduce some of that detail to make sure that you can get it out.
Exactly. And there are tools for that in reality capture. In fact, it'll often generate multiple resolutions of 3D model for you that you can choose from. And there are manual decimation processes that you can use. And so this is the result. We don't have any texture, any color, but we have a three-dimensional model. Over here, essentially what reality capture has created is a single, what it calls a component that it knows that all the photos the camera poses in this one component are all related to each other. And it turns out it's all 25 of the 25 images. And it generated a 3D model. And that 3D model has 5.7 million triangles in it. So this is the large format model. And so that's that result. And then the last step of this process is we want to take the images that each of these photos, camera positions took, and treat the cameras as if they're projectors, project those textures onto this 3D model. So then we get what was the color on each area, on each pixel of this. So it's nice though in the 3D model to really see the level of texture, without any color information. We're seeing grooves in stone surfaces, not just individual stones, but even cracks in stones.
And this is one of the advantages of photogrammetry over LiDAR, in the sense that it may not be sometimes as structured or accurate, but the level of detail is really limited to the resolution of your camera, right?
Exactly.
So you can get incredible. Like if you had taken tons and tons of photos of some of these areas that were around a certain rocks or other things like that, it would theoretically have even more detail.
Absolutely. And in this case, I was just casually walking around with a camera, waiting for somebody to...
And I think that's one of the things that's really important for people to watching, is that this is a free application on a PC, right? I don't think, is this working on...
It is PC only.
PC only. On a PC that you can go out and just take pictures with your iPhone or Android phone or whatever, and then bring it in and start generating models. Now, you may want to get better cameras if you're going to do it professionally, but you can learn a lot by just doing it, because a lot of this is the practice of knowing what it takes to shoot these images is important.
Yeah, I'm going to go ahead and just hit the texture process to get that started, and then we can continue the conversation while this is texturing. And the texture won't take very long at all. But this is definitely one of those areas where we become very expensive friends. You can get started with photogrammetry with nothing more than whatever phone you have that has a camera on it. And you can feed your cell phone images to this. Reality capture does support raw photos, so you can shoot raw and get all the dynamic range out of that. If you do have a a mirrorless or an SLR camera. So all of those advantages can be leveraged in this. But then, like, if you really start to get into it, then, well, maybe I should use a ring flash so that every photo has, the light coming in from around the lens and there are no shadows. And, well, now I need cross polarization. And so, you just start adding to this. I've worked on a project with some students this year where they did photogrammetry of insects. So now we needed, macro lens setups and turntables and, all kinds of like.
And what cameras are you using in those? And a lot of people that I know are using the Sonys because they have a high pixel count for a relatively portable camera.
Mm-hmm. Yeah. So we're using a mix of Sony and Canon cameras.
Mm-hmm.
The scenario there is that the lenses are interchangeable. So, a single sensor platform can be easily configured to capture an entire landscape or, an insect. And it's just a matter of which lenses you're using and how you're leveraging your lighting and all of that. So interchangeable lenses are a real important thing. Some photography rigs, like in this case, for example, I was photographing this wall and I just moved around with a single camera. But you can also get a tripod with a horizontal bar on it and mount 2 or 3 cameras. And each camera has its own strobe with it. And so as a person, you're walking around and you're pulling a trigger and you're firing 2 or 3 cameras at once as you move it around some subject. So you're doubling, tripling the number of photos you're getting, but you're also absolutely ensuring that you have physical distance between those photos, and so that the software can really kind of latch on to all of that.
So now you have the texture there. So then what's the next step?
So that was it. I hit the texture here, and so now we have a fully textured wall. And as I go in, the texture now adds, we can even see brush strokes over the mortar in between these stones.
And you wouldn't necessarily have all this texture in it, but you could, with this 3D model, you could theoretically take this and print it, right? You could print out a model of the wall, a miniature model of the wall if you wanted to. It's 3D
You
data.
could absolutely print a miniature model of this. We could do a few optimizations here. For example, I might want to trim this down really I didn't photograph up here. It's solved for some portion of this, but really I just want some area in the middle, and maybe I'm going to ultimately extract this as some kind of 3-dimensional texture. So there's tools that we can go in here to, I'm just doing a selection tool here, and all right, I can click and drag and say, all right, I'm not going to bother with any of that. So I'm going to filter that out, and that'll trim that out. And so I can reduce the amount of data, and maybe I just want to get this front surface of the wall. So I might go back here and get rid of all of this extra construction that it tried to fill in the gaps, etc. And then ultimately, once I'm at a point where I'm happy with this as a 3D model in reality capture and I want to use it elsewhere, I can go to export. And so here we can export. And I usually export as FBX because this file format will support getting a single file will have the 3D model fully textured, as well as every single camera, the camera positions, and the images are in that camera as well. So that if I open that in Blender or Maya, I can now look through the cameras and I could create my own custom 3D model, etc. So that's the big advantage of the FBX format, is you get really almost all the data that reality capture derived from your photos, all in a single 3-dimensional file. It is very universally importable.
Does it export USD?
It does not export USD. And I think in part that is due to the fact that USD is a little bit different of an architecture. USD is much more than a file format.
Yep.
Now, I know that Apple standardizes on USD, so I don't know why they don't have a USD export, because you can.
Well, it's not. It's that Pixar and many others.
Right, it's Pixar's open standard. Yeah.
USDZ is Apple's, but even Apple is backing back into just USD for a lot of the stuff that they're doing as well. Now, do you by chance have that square project that I sent you? Do you have that? Is it something that's laying around? Is that hard to get
Let me
to?
see if I can find that. I think I
Just
do
to give
have that
someone
in here.
like this takes a little longer to solve, so I don't think we want to do it in real time. But it was kind of a fun project. This is something that I actually took with a Canon. So this was an old Canon. I happened to be in India and for some work in Delhi, and so I went to the square where you could actually walk around the outside of the square, and so I started shooting into the square. And just to give you a sense, this is about 100 and some photos, 180 photos, or 770 photos, something in that range.
Yeah, I used 141 of them.
141 of them, yeah. And so what I did is, you can see what I did. If you look at the top areas, you can see that I walked and shot little pans, all the way around it. So you can see the white areas there. Those are the photos that I took. And so I just kept on walking down and taking a group of photos, and then walking to the next one and taking another group of photos. And so that's how I shot this one. And the level of detail is pretty. I mean, if you were doing something like a effect shot or something, it gives you a lot of data, but if I think you can see inside there, you can see like the wrinkles of clothes and, other things that are, there. It's a lot of data there. But that's the kind of thing that, again, LiDAR would have been very hard. This was just a camera that I had laying around, and I saw an opportunity to take a bunch of photos. But there's just an incredible amount, and that's all 3D data that you see there. So that's a good example of something that you can do with this kind of data. You see all the points.
I'm just going ahead and taking the texture off, so you can just see the raw mesh detail.
Yeah,
and
so it's a couple polygons there.
I mean, this transforms your behavior when you travel.
Yeah. I have to admit, this was me. I was doing another job in Delhi, and so this was my day off, or what we call a safety day there. So I was there the day after the event and didn't have anything else to do. So I went to Old Delhi, and I got some good food and hung out with some friends, but shot this as kind of like, I don't know what I'm going to do with it in the future, but I'm going to go ahead and shoot it because I'm here. And you do get into that habit of grabbing onto cliff walls, random pieces of architecture, and you just and the best thing is that now that these tools are so accessible, you can go do them. You're not really doing a lot of work. You take them back in and you throw them into the system and you cook them, and you just see what came out the other end. And then you look at if something didn't work, or you didn't get coverage, or you didn't see it, that's your learning opportunity. And then when you need it, and what I recommend is, I go through stints where I'm doing 2 or 3 models a day of stuff that I'm, just again, walking around. I'm taking a walk. I'm going to take a bunch of photos of something. And your brain starts to calculate what it takes to actually get it done. Hey, Rick, did you want to add something?
No, I was raising my hand for a previous comment.
Oh, got it. Okay. Did you want to? I didn't know if you wanted. Was there something else that you wanted to mention there? No.
Not for this particular topic, but I will for the future.
Okay, cool. Go ahead, Courtney.
I was going.
I'm sorry. Go ahead, Nick.
I was just going to add that that one of the things that is really great about reality capture in particular, it's a genuinely professional tool. There are a lot of photogrammetry tools out there that are just photogrammetry, meaning just solving the mathematics of the photos. And Alex, you were saying that was, you got started 30 years ago. I feel like I'm a newbie, having started 20 years ago. The mathematics were developed in the 1800s. And the thing about reality capture is it has entire optimized workflows specifically to solve for the use of drone flights and calibration targets, ground control targets that are, patterns that are left out on the ground specifically for calibrating your drone photography sessions. There is an optimized set of tools for combining LiDAR results with photogrammetry. And so you can get highly, highly accurate real-world 3D models of very large spaces, whether they're rooms or buildings or entire, multi-acre sites. And these results can be used for everything from, literally planning construction projects to planning your pre-production for various shoots, because you can create a one-to-one digital twin of something, some space in the real world, and then start dropping in digital twins of your cameras, of your crew, of your grip equipment, and all of that, and really get an understanding.
It's really saved us a lot of times. I use either photogrammetry or I have a small LiDAR system that I LiDAR most place. If a place will let me LiDAR, I will LiDAR every space that I go into. Mostly because I own the hardware, so it doesn't cost me a lot to walk in and push a button a couple times and walk around and gather that data. But later, when we're trying to figure out layouts of like how far, what does that lens actually have to be, or how far, where can I put that camera? Is a tripod going to actually fit there? Those are all things that become useful. Now, this is where did you shoot this dinosaur head?
So this was just, again, this changes the way you travel. And so I was just at a museum. I think there's Academy of Natural Sciences in Philadelphia. And, they have, I think this is actually manufactured from a mold. But I could walk, I actually, reached inside it. There's camera shots here that are inside the mouth of this thing,
Exactly.
but I was like, oh, well, I don't know how often I'm ever going to get around to doing this. So, again, this is 392 images I took around this thing, while probably the rest of my family was enjoying some actual demonstration or something. And then I'm off to the side, just shooting photos of this thing. But I've brought this into Unreal Engine. I've put it into scenes, and again, it's just, oh well, this is there, so I'm going to get it. So I just thought.
I have a couple of questions about the capture and the type of camera. Do you have to make sure that you stay on the same lens for all of your captures? Since the depth of field and vanishing point changes from the length of lens to length of lens, and do you have to turn off things like computational photography if you're using an iPhone, where it would could blur things in the background, or it could change things computationally? Will that screw up the calculations to create the 3D image?
So with the advent of today's modern GPUs, you can get away with some of those things. But the reality is you do want to have as close to a raw image from your sensor as you can possibly get, so that you're processing essentially native pixels. So absolutely, I would deactivate any kind of background blurring and such. You can, you can adjust your mechanical zooms if you're using a zoom lens, but it does it just makes the calculation more taxing because there's more variables for the software to operate on. But it used to be that the best way of doing photogrammetry was to only use raw photos from a camera with complete EXIF data recorded into each image, so that the software would read the lens, the manufacturing of the lens, so it knows what model it is.
Whatever barrel distortion.
Yeah, exactly. So it would account for all of that.
Mm-hmm.
I mean, realistically, again, this is optimized for running on GPU, so it will parallel process. And so it is capable of solving with variable zoom lenses. In fact, there is an optimized solve solution for just using video. So you could shoot a video, and if you're going to shoot video, maybe shoot a high frame rate video so that you have less motion blur. I mean, really, blur is the worst.
Can I ask you, how does it deal with things, if you don't have control over the environment, what about things that are moving, like trees that are blowing in the wind, or people that are walking through an exhibit in the museum? Does it just discount those and remove those from the point cloud? Anything it calculates as moving from one camera position to the next camera position, other than the camera that's moving?
There are branches in the processing that will attempt to identify those kinds of things, but they're not always perfect. So if you have someone in the background sitting in a chair like this and they're moving like this, you can actually throw off your results as a result of that, because the system's going to start to recognize some patterns there and think that those are not moving. So you certainly want to avoid as much of that as possible. An ideal scenario is, a controlled studio, controlled lighting, and all of those sorts of things. But, again, sometimes the reality is you're just on an excursion, you see something of interest, and so you just shoot what you can. And again, the software and doesn't cost you anything, and it does take very little time to process it. And even a failed solve on trying to take an advantage of an opportunity like that can be educational. Like, I didn't think about this thing in the background. I'll watch out for that next time. Or I didn't realize there was so much glossy elements to this, and the light's changing from one photo to another. And so the more you do this, the more you practice. It's like learning a musical instrument. The more you practice, the better you get at it.
And if you're using that rig with, let's say, 3 cameras mounted on a bar that you're moving around, do you have to make sure that the lenses are matched between the 3 cameras, or can they have different manufacturer lenses, et cetera? Is that going to screw up the calculation if they're 3 different camera images that are thrown into the group from different manufacturers, different lenses, and perhaps even different focal lengths?
Again, the optimal scenario is that all of those are the same camera model, the same lens model, and
same
they're all matched.
Do you have to also lock off the f-stop? Yeah.
Yeah. If they're not, it will solve through that. And it may take longer, and the results may be less than optimal. So, again, if you have the luxury and the ability to have a matched set of cameras and lenses, by all means, use that. But if you're, you have access to 3 different cameras, and you have a setup where, I know I can use this wireless transmitter to automatically trigger all 3 to photograph all at once, and, Frankenstein together a rig, go ahead and try it out and see if that's a better result. Then you could always use just all of the images from one of those cameras and see how that turns out.
I'll often I've done some shoots where I'll shoot from a drone, and then I'll shoot with a different camera from a different angle. What I'll do is usually you kind of want to, like Courtney, you were mentioning like people moving. You want to kind of weed some of that stuff out to begin with. But what I'll do is I'll process like the drone separately, and then I'll process the ground shot separately. And then through control points, you can tie the 2 together then. And then, or like interior shots, you can then do control points, tie the shots together or the scans together, and then to create one complete scan from those.
Exactly. So, what Rick is alluding to is that there is a feature in Reality Capture. I don't know if you're seeing my screen right now, but under the alignment area, you can use add control points, and that will allow you to mark different spaces across different images. So I'll go to a view that has multiple images at once, and I'm just holding my 1 key down as I click one image, and then my 2 key and another image, and the 3 key and another image, and I've got a few different images displayed here, and so I could mark some known spot across multiple images. Let's just I'm going to just say the corner of this pedestal, for example. So if I click here, I get a zoomed in view automatically. And all right, now I've got that corner marked there. And this is that same image, but here's another image here. I can mark that corner, and I can mark it here. And so this is the process of placing a control point. And now that's all triangulated based on where those images are across this one component. And so I could have a component that was generated from a handheld camera, another component that was generated from a drone. If both of those sets of images have visibility to this corner, and ideally you want to do this with 3 to 5 minimum little reference points, and then I could identify those across the different image sets. The software will then recognize, these are all the same thing, and combine all of that.
You guys hear me now?
Yes, you're back.
Okay. I thought it was an internet problem, so I spent a lot of time trying to figure out the internet, and it's not. I plugged my computer, if you're wondering, so we don't have to answer this question later. I plugged it into a lower output of my adapter. Instead of the 100 watt, it was plugged into the 30 watt, which is not enough to run Zoom for an hour or for 2 hours. so when I looked up, I saw that the power was down. Let's go ahead and jump into the questions.
Okie dokie. First one up is from Eric Hertz in Hartford, Connecticut. Says, if I set a fixed frame rate in my Unreal project, and my system cannot keep up with the live rendering. Does Unreal drop quality or make any other changes to keep up with the desired frame rate?
I don't know if that's really. Yeah, go ahead, Nick.
Yeah, it's not necessarily related to reality capture, but I think it just drops frames. When you set a fixed frame rate, it's going to do its best to get the quality that you're asking for, and it'll drop frame rate rather than drop quality.
It's much simpler to throw away a frame than it is to lower the quality of the image. so generally, it will throw the frame away. Next question.
This one comes in from Douglas Carmichael. He says, for capturing process, do you need a tripod or a similar stabilization device, or can you just hold your phone during the capture?
Go ahead, Rick.
Ideally you don't want it to be shaky, but you can hand hold it. You can put it on a tripod. You can put it on a pole, on a drone. I think the real key is to just get a lot of overlap and a lot of images that are something that can basically overlap to solve together, so they all have enough to process properly. So no, you don't have to have a tripod. You can hold it, you can tripod it, gimbal it, whatever. Just make sure it's not blurry. There aren't, hopefully not things moving and things like that.
Yeah, I would say the vast, like 95% of all the photos I shoot with photogrammetry are done by hand. I hold it still, but I'm doing it because I want to be able to move. And the problem is that if you start putting on a tripod, you're not going to take the variety of shots that you need to get a good capture. Go ahead, Nick.
Yeah, so it's going to depend on the situation, really, it's like with a lot of things. So if you're shooting a very small object and it's on a turntable, in that scenario, you're going to want to use a tripod, and that way your camera is as stable as possible. Also, if you're shooting in a dimly lit scenario, a tripod's going to be good for stabilizing the camera. Whereas if you're using strobes, handheld is perfectly fine because the amount of light being used by the photograph is only lasting for 1,000th of a second. And so you're not going to get motion blur. So I think that, if you're thinking about how do I optimize, the very first thing that you want to optimize is lack of blur. You want everything that's related to the subject you're photographing to be sharp, and you want to avoid motion blur. And if you can, you want to have as deep of a focus area as possible. So, a higher f-stop number with more depth of field in your focus is going to be more useful for photogrammetry than something that's shallow depth of field, because you lose the background and foreground detail that can be used for solving three-dimensionality. So solve blur first. That's your top priority.
Well, and would you say also solve zoom? Like people will tell you that you can change the focal length, but I don't do it very often. Like I usually am using either a fixed lens, or the 24 to 70 that Canon makes actually has a lock on the 20. You can open it all the way up to 24 and you can pull a little switch and lock it. If I don't have that, oftentimes I'll even tape it, to tape my lens to make sure I don't change that focal length, because it does make the calculation a lot more complicated.
Exactly. Yeah, I think that, and so you zoom with your feet.
Yeah, exactly. Go ahead, Courtney.
And so if you're using a drone, I was going to have the question that you solves the wide-angle lens problem, because most drones have really wide-angle lenses and everything's generally in focus. But do you capture video, or and extract the stills later, or do you have the drone move from point to point and capture short duration stills, or short shutter angle stills?
So from my workflow, in the past, I would have the drone shooting interval photos. So like some small interval, shooting its highest resolution photos. Now, in part because I don't own expensive drones. My drones are in the $1,000 to $1,500 range. Though at that price point, the Ultra HD that the video captures is darn near the same resolution as the full resolution photographs. And so these days, with the current version of reality capture, I actually favor shooting video, capturing as many frames as possible. And then Reality Capture can actually import the video, and you can select, well, how many frame intervals do you want to go between still image grabs? And it'll extract the photos for you and work on those. And it solves perfectly well. And I've tried a few locations with both approaches. And generally, I'm getting better results by shooting the video because I have far more frames to work with than I get with doing an interval photo. Like if I do an interval photo at 1 photo a second or 1 photo every 5 seconds, that's dramatically fewer frames to work with than if I'm shooting 30 frames a second video. And so if I just move the drone gradually across a space at 30 frames a second, I'm getting a ton of overlapping information to work with, and I get a really high resolution result.
And for very large spaces, there's a software or a service that I've used in the past called Drone Deploy. And you just sit there and you go onto a Google map and you outline, like I did it for a golf course, and I just outlined the golf course, and I said I want that, and it just takes off. It works with DJI drones and just takes off and starts doing a grid. It just starts going back and forth. It took 3 batteries to do the whole golf course, and it would literally just come back, land. I swapped the battery out, and it would take off again. Like it was just, was
capturing stills or video?
It was capturing stills. It was capturing stills, and then you'd get all those photos, and you upload it to their service, and it comes back down as a 3D model and a TIFF file and a bunch of other things. Like you were able to just grab that data. It's a pretty amazing service for it. It's a little expensive now. I think I had it on a very early on, and I haven't played with it recently, but it's pretty slick.
I was going to mention. Mind if I chime in? I was going to mention that I use Drone Deploy too, but I usually use 3 methods for when I use a drone capture, and that's one is like a grid like that, and then if it's like a building or an object, I'll do orbits, and I'll do it from different elevations.
It does an automatic orbit, doesn't it? I mean, it'll do orbits itself as well.
Yeah. So yeah. I'll do a grid and orbit, and then I'll go up and I'll get details up close and try to get as close as I can, and so combine those 3.
Yeah, and a lot of these tools, I was just talking to someone that was dealing with real estate. I think there's a lot of these tools that we're going to, as these get easier and easier to use, there's a whole service waiting to happen, which is, going out and building, more complex 3D models of houses that are for sale and so on and so forth that you can eventually walk through or, jump through. There's more and more people are buying houses before they get there, or at least trying to decide what houses they're going to tour before they get there. And so I think that it's a really interesting for expensive houses, it makes sense when you're doing a house over. Unfortunately, for those of us who have done some real estate in the background, I think a lot of people are excited that it costs less to buy a house. Now you get a lower percentage of the real estate agents, but that also affects the whole ecosystem of what those real estate agents were paying us to do things like that. I don't do it anymore, but I would have been like, oh, that's a bummer because that's going to take money out of my pocket too. Next question.
Next one comes in from Dave Troutman in Edmonton, Ontario. He says, when you shoot under even lighting, is there a way to create more contrast or changing the lighting to appear more directional in the software?
Go ahead, Nick.
So adding the lighting to be more directional comes ultimately in the downstream tools like Unreal Engine, or if you brought it into Blender, it's when you're rendering. So when you're capturing and you're creating the 3D model, you actually want the lighting to be as even as possible and exhibit as little artifacts of direct lighting as possible. That way you get what we call an albedo of the colors, the color without the impact of lighting. And actually, professional photogrammetry technicians work really, really hard to get that kind of lighting, and including using ring lights around their lenses and strobes, so that there's a strobe that's firing at 1,000th of a second, and it's shining light from all around the lens so that we're eliminating as much shadow and also as much environment lighting as possible. And again, using cross polarization, any of the flare reflection from that strobe gets filtered out. And so we're just seeing the diffused lighting bouncing off the surface. When you have that, it is much easier to get something that looks effective and real in either your rendering software, whether it's Unreal or Blender or whatever, because now you can position lighting the way you like, you can adjust your color temperature, and you're getting no artifacts from when you actually captured the photos in one particular situation. You can now relight in any way you like.
Next question.
Next one comes in from Tommy Shantz in St. Paul, Minnesota. He says, is varying focal length and or distance from the subject encouraged?
Nick?
So varying focal length, meaning the zoom of your lens, is not encouraged. Alex was noting earlier that he likes to use the 24-70 Canon lens. I love that lens. Also, setting it as wide as possible, taping it so it doesn't move. That's going to help the calculation be faster and more effective. And but changing the distance to your subject, and we were talking about zooming with your feet. It's good to start at a distance to capture a object so that your entire object is within the frame and you've walked all the way around it and high and low. And so now that provides the software a sense of the overall geometry. And then you can walk closer and get all the fine detail with close-up photos, still the same focal length. You're just much, much closer to the object of interest. And then those closer photos give you more of that finer detail. Software will blend all of that and ultimately create the 3D model from that. So it is encouraged to be photographing from different distances. It's not encouraged to change your focal length.
Next question.
Comes in from Rob Collins in Kansas City, Missouri. Says, would using a slow, stabilized video make a good scan, or does video have unique problems with reality capture?
Go ahead, Nick.
Yeah, video can make a good scan. One of the things, down the road as we cover these 3D topics, we'll be talking about metahumans and eventually being able to scan a face and make a 3D metahuman with a scan through reality capture. When I do that, I use an iPhone at high frame rate, whatever the highest frame rate I can get out of that, and sweep the phone around the face of the person so that I get a lot of frames very quickly, which results in the least amount of motion from the person possible by using a single camera. I mean, a professional feature film setup would use an array of maybe 100 cameras that all photograph instantly at the same moment. So there's no variance in terms of the person's breathing or heartbeat making their geometry move. But a high speed, high frame rate video that you then extract frames from can be extremely effective in its own right. So there are some unique, I wouldn't call them problems, but challenges with video. Video does tend to be a little bit lower resolution than you can get from a high megapixel camera. Sony's cameras are 15, 18 megapixels these days. And so there's a lot of detail you can get in those that you're not getting out of a video. The video tends not to be encoded with the exact lens model and lens length. I mean, for most consumer and even prosumer cameras, when they shoot video, the metadata doesn't encode exactly what lens was being used and what lens length was being used. And that is routinely encoded into the metadata of photos, even with a cell phone. And so those types of things do help the calculation. But again, there are a lot of scenarios where a really good, sharp, no motion blur video can be every bit as effective, if not more effective, than a small set of photos.
Good, Courtney.
So when metadata is included in the files, does reality capture actually access that metadata and use that in its calculations if there's lens data in there?
It does use it to inform the calculation. So it'll treat it as a shortcut. It'll say, oh, okay. Rather than, I have no idea what this is. Let me try everything from, 10 millimeters all the way up to 200 millimeters or whatever. Instead, it says, oh, okay, this is saying that it's an 18 millimeter lens, or it's set to 18 millimeters. I'll start in that range. And then again, it'll use the pixel data itself to dial that in and solve for, its estimation of lens distortion and such.
So it kind of does a self-calibration for that particular lens from the data that it was captured, even though it's not a test charge or something.
It definitely gives it a shortcut, and it does speed up the calculations because it takes away quite a bit of the guesswork in the algorithms.
Next question.
Next comes in from Douglas Carmichael. It says, can reality capture be used to create realistic walkthroughs of space, replacing time-consuming modeling?
Go, Nick.
So absolutely. It depends on what you're hoping to achieve out of it and how effective you are in your photography. So, if you wanted to create a digital double for visual effects shots, you're going to use the photogrammetry and maybe some LiDAR as well as information to inform an artist to create generally, bespoke 3D models to recreate that space for the needs of the visual effects. So if you're going to explode a kitchen, for example, there are approaches to the way you would 3D model that and process that through something like Houdini to make that explosion effect most effective. And, reality capture photogrammetry software is not in any way thinking about that per se. It's saying, hey, these are the optical patterns I noticed, and here's the surfaces that correspond to that. So if you're doing pre-visualization, though, you could walk through a space. You could video record with a 360 camera. You have to tell reality capture that you're using a different lens model with that and fisheye lenses and such. But you'll get a really good, approximation of the space. Maybe you didn't remember to catch every last little nook and cranny of the room, so you get some large triangles and such that like, I wish that wasn't there, but it still gives you the layout of the space, and you can see what the lighting is and how you would fit all of your grip equipment into the space that you're planning to be shooting in. So you can absolutely go through a space and very quickly with a minimal amount of individual, human effort, come up with an effective 3D model. And that's a really, really good value for this tool set.
What's interesting is some of these drones have LiDAR in them, so they can tell where they are and make sure they don't run into things, mostly object avoidance. But I could see how you could get a little drone that has those little protectors on them, little things that go around their blades to make sure they don't run into anything. And using their LiDAR along with their camera, you could theoretically just set them loose in a house. And with a little AI and a little bit of processing, they'll just wander around and gather all the data that they need. In fact, if they were doing camera to cloud or something like it, they could theoretically be delivering those photos in real time to a server that's in in real time building out the model and saying, oh, go take photos of this, oh, go take photos of that, and so you could just leave a drone running in there for 20 minutes and it would probably whatever, do it for a couple hours and it would just sit there and gather every little bit of data that it needed to model a house. It's really interesting. I mean, there's and the advantage of that 3D model as opposed to what you see a lot of times in these, there's a variety of different tour things where they're doing 360s. The 360 is fine, but if you get that data to be really high quality and relatively light, now that's something you can do with MetaQuest, with a Quest, with a Apple Vision Pro, where you could have the geometry there and be able to kind of make that actually happen. Yeah, go ahead, Courtney.
So you could just mount a camera on your Roomba and have it automatically
exactly.
go around.
But it's only one plane of data. The advantage
have a little
of
telescoping
the drone
thing that goes up. And
down. Why don't you just turn the Roomba into a drone and then it can just take off and land to the next floor, and that'd be a whole. Get each step, just take off. Go ahead, Nick.
One thing I'll note is that with the iOS LiDAR in the Pro devices, I'm using 3D Scanner app, which is a free app on iOS. And one of the advantages of that type of tool is, well, again, if you have a Pro phone or iPad, I can scan a space with that. And the software is giving me real-time feedback as to
what you've
my
covered,
scanning based on the LiDAR. And it creates a low resolution 3D model based on the LiDAR infrared point cloud that's being projected into that space. And so I have immediate feedback and I can explore that and I can make some measurements, etc. The thing is that in order to texture that model, it's also constantly taking photographs.
Yeah.
And so I can afterwards, when I get back home, get all of those photos out of that software and process those very same photos with reality capture and actually get a higher quality, higher detailed 3D model from that same excursion. And so, a lot of these LiDAR solutions, and there are automated, I know Leica has automated LiDAR drones that are photographing and using LiDAR at the same time. And they're, you could just tell it this building and it'll track
right
around the building. So those photos can then be used in photogrammetry, like in reality capture, and then merged with the LiDAR data itself to create a highly effective, highly detailed model.
Thanks so much for your time. Thanks, Nick, for putting that little demo together. It's good to see you, Rick. It's good to have you here. So hopefully Rick will come back on these Tuesdays and be part of the conversation. And of course, Courtney and Jeffrey who left. Thanks to everybody who came on today. We really appreciate it. We're going to keep on coming back to this because photogrammetry is really moving into the sun. Like a lot of us have been doing this for a very long time, and it's going to become more and more important as we see more and more of these a variety of tools coming out that are going to be useful. And we want to make sure that as many people as possible here, understand how it works, understand how easy it is to get into, and start to work on it. So definitely jump into this. We highly recommend it. So thanks for all the great questions and thanks to the incredible team on the back end making this possible. Even when my computer died in the middle of the show, 2 days in a row where we've had little glitches here. We're gonna try to knock that out tomorrow. But thanks to everyone who's able to kind of dance with that and make it all possible. Today we traveled 35,000 miles in the Tall Traversal. That is 56,000 kilometers, and that is 276 million bananas for scale. All right, let's go ahead and jump into after hours. I got to rebuild this setup here.
You're running your computer off a UPS? That's not.
No. It was. I have an adapter, and the stupid adapter has two 100-watt things and a 30-watt one, and I have to put a big mark thing. I got to take a Sharpie. Printed very small, and I thought of it as top is the right one, and I didn't think that. Oh yeah, I reversed the angle of it. So when I put it in the top one, I put it into the 30-watt.
So it's the power adapter for your MacBook or whatever.
It's the power adapter. It's got 3 USB-Cs and 1 USB-A, and I just didn't. I just got it. I got it reversed. So anyway, it's stupid, but it happened.
By the way, it's good seeing Rick again.
Hey, Rick. It's good to have you
to
here.
See you. I'll be coming back.
Rick's gonna bring some. What are you bringing on, Rick? In a month?
LTX Studio.
LTX Studio. Have you seen that, Nick?
No, I couldn't quite hear that. What was that
LTX Studio.
Oh no, I haven't.
I've been looking